is about demonstration of why numpy arrays are advantageous over lists. And this is in terms of three things, in terms of memory, speed, and flexibility. So let's get started with the first demo, the memory comparison between numpy arrays and Python lists. So I'm going to use a couple of libraries. Obviously the numpy library. So I import numpy as np, and then I import sys library. Now we all know the list, right? Python list is simply the collection of elements, something like this, right? Okay. Now if you print the list or type of this list and the size of this list, I mean to say the length of this list, you get all this information. Okay, sorry, lst. So here is the list, lst, and the type is of classed list, and it is of length 6. It has got 6 elements, right? So one important thing is you pause at your will and code along. Please make sure you're coding along to understand better. It makes your learning more enhanced. Now, right, so this is a list. So let's also create a numpy array, right? So arr is equal to np dot array. This is a method which converts a list into a numpy array, or in other words it generates a simple numpy array, np dot array, and I pass just simply lst. Okay, and if I print this arr, then you get a numpy array. That's all. See, it's same as that of a list. Now if you want to know the type of this, or let we already know the type of it, it is going to be nd dot array, but still let's see type of arr. What does it give? It says numpy dot nd array. So nd array is the data type of numpy array. Then for knowing the size of it, we have to utilize something called as size, arr dot size. So the size is this. Okay, now uh, I'm going to use sys package and try to find the each element size, so size of each element of that list, using get size of method that is present inside sys package. Get size of lst, this is what it gives me. So this is the size of each element. Now I want to know the size of entire list, right? So in order to know the size of entire list, what I'll do is simply, I know the size of each element, and then I'm going to multiply it with the length of this. So then I'll get the size of the entire list, right? So 120 into 6 is 720. Now I am going to do the same thing similar for numpy array. For numpy array, I have inbuilt methods to find the size of each element, and if I multiply it with the length of the numpy array, I'm going to get what I'm looking for. So for the size of each element, what I'll do is, so arr dot, I'll say item size. Arr dot item size provides the memory of each element, and if you look at it, obviously you can compare 120 with 8, and you clearly see how low consumption of memory is. Imagine this is a list of 6 elements, right? And imagine if this is a list of like 10,000, 1 million elements. So it would be far more efficient. So sorry, not sys, arr dot item size. If I multiply it with the arr dot size, okay, then it will give you the memory of the entire array, right? So this is a simple demo. Imagine that you have a huge amounts of data and you're doing some multiplication or some complex operation. uh, Using lists would uh, will be very tedious and computationally intensive. So numpy arrays would be far more efficient and far less memory intensive. So that's how that this is a simple demo of it. Okay, now let's go to the second demo, which is the speed comparison. So I'm going to import time a package and I'm going to utilize it and try to see how much time a simple operation would take when we are using less python less compared to that of the same kind of operation being done using numpy arrays. Okay, now what I'm looking is, let's say I'm looking for, like, if this is a simple list, and there's another list, say 5 6 7, and I'm sorry, 5 6 7, and I'm trying to find a result which would multiply these two element wise. So 1 into 5 is 5, 2 into 6 is 12, 3 into 7 is 21. So I'm looking for something like this. I have a list, two lists, and then if I multiply element wise, then I would get, the multiplication of it. So to do this, let's take a simple, let's say a is equal to this, then b is equal to this, and to get this result, what we need to do is simply utilize uh, list comprehension and then zip function. This is how I'm going to do for I comma j in zip of a comma b. Now if you're wondering what this is, just let me quickly demonstrate what zip is. Zip of a comma b, if you just zip it, you're going to get simply a, class. Okay, then you'll get something like this. It's 1 5 2 6 3 7. So it associates each element, corresponding elements. Now what we have to do is simply multiply these two things, right? Multiply 1 and 5, 2 and 6, 3 and 7. That's where I utilize this simple list comprehension. Okay, list comprehension, and uh, I multiplied it. So that's what it is. So wait a second, it's 1 times j, I times j. Okay, um, so you're simply multiplying and you're getting the result. Okay, now I want to know how much time it takes for this operation to be done, right? So simply I'm going to use, I'll create size is equal to this and a is equal to range of size, and b is equal to range of size, and we'll see what happens. So this is the time it takes for, a size of so long, so huge size arrays, two huge size arrays I'm trying to multiply, and this is how much time it takes. Okay, now I want to do the same thing, similar thing, using a numpy array. Okay, so this is for Python list. Now let's see for numpy array. Now I'm going to use a is equal to np dot a range size. Now let's not use a, let's use x. Okay, and then y is equal to np dot a range. If you're wondering what a range is, which you would look in for future videos as well, is another way of generating numpy arrays, and a range is similar to that what you see as a range function in Python list, a range of possibility. Now if you want to multiply this two arrays, you don't need to you don't need to zip them, then you don't need a list comprehension method, right? So you simply just put z is equal to x times y, and it does the element wise operation. That's all. Okay, so and all what I'll do is I'll just use the same thing. I'll use start. Okay, so now what I'm trying to do is I'm taking two lists of size 10 power 6. Okay, there are two lists of size 10 power 6, and I'm element wise multiplying it, and I'm trying to record the time. Now I'm also parallelly uh, trying to find two numpy arrays of 10 power 6 size, and multiplying element wise I'm trying to calculate the time it takes, and I'm going to compare the time which takes lesser time. That's the goal of this demo. So let's run this cell. Okay, so this is the time taken by list when two lists are multiplied element wise. This is the time it takes, how much time it takes, and this is the time how much time it takes when it is an numpy array. And clearly what you can see is that numpy array are very fast, very fast compared to that of um, Python lists. Okay, and third demo that we are going to do is flexibility. There are certain operations that we have seen. One of the operations to simply multiply element wise of two arrays, you just say x into y. But for if it is a list, then that's not very possible. That's not possible. Now there are other operations similar to that, and one operation, such operation, is as simple as this. There is, let's say you have a list like this, and if you want to add like an 2 to each element of it, okay, what would happen? Is this possible with a list, Python list? So I want the result, it's not possible. I want the result to be like, you know, 1 plus 2 is 3, then 2 plus 3 is 5, 3 plus 2 is, oh sorry, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. I want this result, and it's not possible with list. So if let's say this happens to be a numpy array, okay, let's say p is a numpy array, or arr is equal to np dot array. Okay, this is a numpy array, and I want to add 2 to it, right? So let's say print arr plus 2. So what would happen is you get element wise. So a simple int can be added to an numpy array, which is not possible when it comes to list. So there are a lot of other things too in this similar lines, and that's how flexible numpy array is.